Okay, okay, so this is an interesting problem. We are asked to find the mechanical advantage of the mechanism. Okay, so assuming that you are driving the mechanism anti-clockwise, so you are basically applying torque, and what is asked is how much force you will be getting. So I'm going by just the power equivalence or power equal. So the input power is T into omega, torque it to angular speed of this, and here obviously you will have some kind of a force, because okay, so let's say you are applying torque, so there will be some kind of a force here, so which is, you can say, the load. Okay, so force into velocity, okay, is what is your resistance. So force into is the output power which you have to meet, and T into omega is the torque which you are applying. Okay, so this is your power balance. Now mechanical advantage will be your output effort, okay, by input effort. Now this can be written in terms of torque ratio or force ratio. So output effort is what is your F, and input effort, I would say, directly can't be torque, or output effort also you can measure in terms of torque. So it will be proportional to this. What I can say is something, it will be proportional to this, not exactly, because the ratios don't match, but the idea here is that F by T, so mechanical advantage will be some kind of a function of force by output force by input torque. Output force by input torque is omega by V. Now as theta is 0, now remember that this when this crank is like this, and when theta is negative, let's say, you can have something like this also. Okay, and the other case when theta is positive. Okay, so when it is moving from this position and coming to this position, okay, and going to this position, so in all this, what happens is that if you concentrate on the slider, okay, when it is very close to 0, but on the negative side it's going to 0, the slider moves in this way, the speed is in this direction, but as it crosses 0, the slider has a tendency to move towards the left. So at 0 it changes the direction, the slider direction changes, and hence the speed is, the velocity is 0. I can say the velocity is 0. So whatever may be omega here, it has to change the direction, it has to come to rest and then change the direction. The speed is 0. Okay, it changes the direction. I can say the speed is 0. Okay, so as the speed is 0, so we can say that whatever torque you apply, you are not getting any advantage, you are not getting any mechanical advantage. Okay, so going by this, the mechanical advantage is infinity. Okay, irrespective, so the other way to argue is that irrespective of whatever torque you apply, okay, it changes the direction here, and it can support a very large value of load. It doesn't matter how much torque you apply, because of this kinematic constraint it has, that as theta reaches to 0 from negative and then tries to cross to 0, then irrespective of the torque you apply, it can support a very large load, because velocity is 0. So going by this analogy, so mechanical advantage is infinity. Okay, this is a very good question. Thank you.